Section 8.7, Linear Inequalities, Part 2. If we have inequalities written of the form ax plus b is less than c, ax plus b is less than or equal to c, ax plus b is greater than c, or ax plus b is greater than or equal to c, then we call those linear inequalities. If we have inequalities that look like c is less than ax plus b is less than d, and c is less than or equal to ax plus b is less than or equal to d, those are called compound inequalities because what you're actually doing is combining two inequalities into one. So our general steps for solving linear inequalities will look very similar to our general steps for solving equations. The first thing we want to do is simplify by removing all of our grouping symbols. So that would be use distributive property, and then combine like terms if you have any. Then we're going to use our addition property of equality so that we get our constants and our variables on opposite sides of the equation. Then we're going to use the multiplication or division property of inequality, or of equality, to multiply or divide both sides so that we get the coefficient of our variable to be 1. Here is the main difference between equations and inequalities when we're solving them. In an inequality, if you have to multiply or divide by a negative number, you have to reverse the direction of your inequality. So if you have a less than problem, you'll change it to a greater than problem when you multiply or divide by a negative number. And then you should check by selecting one number that would be in your solution to your inequality. So let's say we get finished and we get x is greater than 2. Then you can pick any number greater than 2, substitute it back into the original inequality, and then check that it does make that inequality true. Now we'll look at solving some inequalities and then graphing the solutions. We want to solve 6x plus 5 is less than or equal to negative 1. So the first thing we're going to do here is we're going to subtract 5. And we get 6x is less than or equal to negative 6. Then we divide by 6, and x is less than or equal to negative 1. Now notice that we did not divide by a negative, so we don't need to switch our inequality sign. So it's x is less than or equal to negative 1. And now we're supposed to graph that solution. So we'll go to our number line, we'll go to negative 1, and since it's an equal to problem, we put a bracket, and we want everything that's less than that, so we'll come out to the left and shade, and then shade in our arrow. In our next example, we're going to have variables on both sides, so we'll go back and solve just like we did with our equations. I'm going to subtract an x from both sides. And then I'm going to subtract a 4. Then we're going to divide by 2. So negative 3.5 is greater than x. But then we'll want to rewrite this so that our variable will be on our left-hand side. So if negative 3.5 is greater than x, then x has to be less than negative 3.5. So we'll go to our number line now and we'll sketch that solution. So since I have to be less than that, I'm going to make an open parenthesis at 3.5, and then we want to shade everything less than that, so we'll go to the left and shade in our arrow. Now let's look at 6 minus 4x is less than or equal to x plus 1. So this time I'm going to subtract an x from both sides because remember, we will eventually want our variable to be on the left anyway. So we'll have 6, negative 4x minus 1x would be negative 5x equals 1. Then we'll subtract 6, negative 5x, oh, that should be less than or equal to, is less than or equal to negative 5. Then we divide by negative 5. But since we divided by a negative number, we have to flip our inequality sign and make it greater than or equal to positive 1. So when I sketch that, I'm going to go to 1 and we'll use a bracket because it's an equal to problem. And we want everything bigger than that. So we'll shade to the right. Now let's look at a compound inequality. So what we're going to do here is we're going to focus on just this center part, and we're going to ask ourselves, okay, if we were solving that, what would we do first to get that x by itself? Well, the first thing we'd want to do is we want to add 1. So just like we did before, we're going to add 1 here, but we're also going to add 1 to both of our constants in our compound inequality. So negative 4 is less than or equal to 4x, because those have canceled, is less than 12. And then we divide by 4, but again, we're going to divide everything by 4 and get negative 1 is less than or equal to x is less than 3. Now, let's graph this, and I forgot to include our number line. So we want to graph or include everything from negative 1, and since it's an equal to, that's going to be inclusive, so we'll make a bracket there, to 3, but 3 is not equal to, so we'll make a parenthesis there, and then we want to shade the parts that's between it. All right, in this inequality, we have 5 is less than or equal to negative 3 minus 2x is less than or equal to 13. And I'm going to rewrite that so that our x part is first in the center part. So let's make it negative 2x minus 3. And now we'll solve from there. So we'll add 3 and get 8 is less than or equal to negative 2x is less than or equal to 16. And we're going to divide by negative 2. And I get negative 4 is greater than or equal to x is greater than or equal to negative 8. But now, since this is a greater than or equal to problem, what I want to do is remember what this, or think about what this means. If negative 4 is greater than or equal to x, then that means x has to be less than or equal to negative 4. And if x is greater than or equal to negative 8, then negative 8 would be less than or equal to x. So I can rearrange this inequality to look like negative 8 is less than or equal to x is less than or equal to negative 4, which means that we want all the numbers as our solution between negative 4 and negative 8. This time they tell me to write my solution using interval notation, so we'll write that as negative 8 to negative 4, and since these are both equal to problems, we'll put brackets. Our next inequality, 0 is less than 3x minus 5 divided by 4 is less than 3. This time we want to multiply everything by 4 to get rid of the divided by 4 here in our middle part. So we'll multiply everything by 4. 4 times 0 would give me 0 is less than, the divided by 4 and times 4 will cancel and give me 3x minus 5 is less than 12. Then we can add 5 and get 5 is less than 3x, those are going to cancel, is less than 17. And then we'll divide by 3. And we get 5/3 is less than x is less than 17/3. And I'm going to go ahead and leave those as improper fractions. And now I want to write my answer in interval notation. So we'll have 5/3 is my lower answer to 17/3 is my upper answer for my interval. And because these are not equal to problems, we'll have parentheses. So that's my solution. Now we'll take a moment and look at a couple application problems. In our first example of applications, we have a math student who has grades of 85, 98, 93, and 90 on 4 different exams. He wants to have at least a 90 or better to receive a grade of an A. So what would his 5th exam score have to be so he averages 90? Well, we know that we want 85 plus 98 plus 93 plus 90 plus his missing score, so x is going to be our 5th exam score. And when I add that up and divide by 5, I want my average to be greater than or equal to 90 because he wants to have at least an A. So if I add up my scores of 85, 98, 93, and 90, I get 366 plus x divided by 5 equals 90. So now we could multiply by 5 and get 366 plus x equals 450. And then we'll subtract the 366. And I get that x has to be, well, it should be greater than or equal to, not equal to's. Greater than or equal to an 84. So he has to have a minimum score of at least an 84 on the next exam if he wants to average at least a 90. In example 14, we know that Ellen is going to buy a total of 30 stamps. Some of them will be 28-cent stamps and some of them will be 44-cent stamps. And she's going to spend $9, or she has at most $9.68 to spend. So what's the maximum number of 44-cent stamps she can buy? So let's let x equal the number of 44-cent stamps. Well, we know that if we take x times 0.44 plus the number of 28-cent stamps she's going to buy, but if x is the number of 44-cent stamps, then 30 minus x is going to equal the number of 28-cent stamps. So if I take the x times 44 cents plus 30 minus x times 28 cents, that's going to give me a total to spend on stamps of less than or equal to, no more than $9.68. So 0.44x plus, we'll use distributive property, 8.4 minus 0.28x is less than or equal to 968. Now we'll combine like terms, and we get 0.16x plus 8.4 is less than or equal to 968. And now we'll subtract 8.4, and we get 0.16x is less than or equal to 1.28. Divide by 0.16, and I get x is 8. So the number of 44-cent stamps that Ellen is going to be able to buy would be 8. But then that means she would also be able to buy 22 28-cent stamps. We're now to the part of the video where you need to pause the video and work on these 6 practice problems. Once you're done, restart the video and then check your answers. Here are your solutions to the practice problems. Make sure you correct your answers or mark those that you've missed that you need me to go over, and we'll talk about these the next time we're in class.